Hello students, in this video I am going to discuss about the discovery of charges and their properties. First of all, we will have a discussion on the history of discovery of charges. It is near about 600 BC when a Greek philosopher named Thales, he observed that when amber, it is a hardened sap which is obtained from a pine tree, hardened sap. When this amber is rubbed with woolen cloth, it acquires the property of attracting the light objects like the bits of paper, feather of birds, and dry leaves, the pieces of dry leaves. Then in 1600 AD, Dr. William Gilbert, he, with his experiments, he said that it is not the amber and woolen cloth, but there are many other objects which, when rubbed together, they acquire the similar properties of attracting the light objects. Then he said that the kind of electricity which developed between the bodies due to rubbing of each other, due to this friction, is called as the frictional electricity. And this frictional electricity is static in nature. As the charges so developed due to friction, they cannot move from one point to other, means they cannot flow. So they are static in nature. Now experiments show that these charges which develop, the kind of electricity that develop on the bodies is of two types. One is positive and negative. Actually, the names were initially the names were called like vitreous and resinous. And in fact, this name positive to vitreous charges and negative to resinous charges was given by Benjamin Franklin. It was given by Benjamin Franklin. And the experiments show that these charges are of two types, and the kind of charges that develop on the glass rod, flannel or woolen cloth when they are rubbed with silk, ebonite rod, amber, rubber, plastic correspondingly, means when glass rod is rubbed with silk, flannel with ebonite rod, woolen cloth with amber, or woolen cloth with rubber, or woolen cloth with plastic, the kind of charges that develop on these bodies is similar in nature, whereas the kind of charges that develop on these bodies is of the other nature. The charges which develop here are positive and the charges which develop here are negative. So it is about the history of discovery of charges and how they got these names, positive and negative charges. But remember that they are not just like the positive and negative numbers. Here positive and negative only indicates they are different, they are just opposite nature. Okay, next we will discuss about the properties of charges, and in properties, the first property is unlike charges attract, whereas like charges repel each other. The first property is unlike charges attract each other, whereas like charges repel each other. The second property is law of conservation of charge, and it states that the charge can neither be created nor be destroyed, or for an isolated system, total charge is always constant. For an isolated system, the total charge is always constant. Now we can have an example here. In case of fission of uranium-235, when a uranium-235 nucleus is bombarded with the slow moving neutrons, the bulky nucleus of uranium-235 gets separated into two lighter nuclei, barium and krypton. Barium have atomic number 56 and krypton have 36, whereas barium have the mass number as 141 and krypton have 92. Plus we get 3 neutrons plus energy. Now here you can say, you can easily see that the total number of protons before is equal to this atomic number represents the total number of protons or the total number of electrons. So the total number of protons, or you can say the electrons also, before disintegration is 0 plus 92, that means 92. And the total number of protons after is equal to 56 plus 36 equals to 92. So the total amount of positive charge or the negative charge before interaction and after interaction is same. It means the charge is always constant. Okay. Next property is additivity of charges, and it says that the charges on a body are to be added algebraically. We have to it says that the charges have to be algebraically added, just like the numbers. Means suppose if a body have 1.6 into 10 raised to minus 19 Coulomb, and we give it suppose 3.2 into 10 raised to minus 19 Coulomb of charge, if we give further this much charge, then the total charge will become 4.8 into 10 raised to minus 19 Coulomb. Or suppose if it have a charge of E, and if you give it 2E, then the total charge becomes 3E. Means the charges have to be added algebraically. This is the property of additivity of charges. The last property which we will discuss is the most important one, and it is quantization of charge, and this is the most important one. This property states that the charge on a body can be increased or decreased only in the form of a integral multiple of a certain minimum quantity, and that minimum quantity is equal to the charge of the electron. It means Q is equal to NE, the charge on a body where N is an integer. The charge on a body can be an integral multiple of a specific quantity. It means, I will give you an example. It means that a body can have a charge of 1.6 into 10 raised to minus 19 Coulomb. Suppose a body is having this much charge. So if you take out the charge, either its charge will directly become 0. You cannot take out a part of this charge. Means either you can give E or you can take out E. This E is the smallest quantity of charge which can be added or can be taken out. You cannot add or take out the part of this E. Or if you suppose give the charge to the body, then either the body will have 1.6 into 10 raised to minus 19 Coulomb, or directly it will have 3.2 into 10 raised to minus 19 Coulomb. If you add further, then it can have directly 4.8 into 10 raised to minus 19 Coulomb. The body cannot have 2.7 into 10 raised to minus 19 Coulomb. You cannot have the value in between. You cannot have the value of 3.6 into 10 raised to minus 19 Coulomb. You cannot have this value. Means it is just like a you can simply say that if you want to add, if you want to give the charge, you can give E or 2E or 3E. You cannot give 1.5E. You cannot give the half of the charge of the electron. You cannot give the fraction of the part of the electron. either the complete electron, the charge equal to the electron. It is not electron, it is the charge equivalent to the charge of electron. Either that complete value have to be given or it can be taken out. You cannot add or subtract the part of this charge. That's all.